Okay, let's refresh our quadratics knowledge and recall how to solve quadratic equations in a couple different ways. The quadratic functions are very important because for a couple of reasons. It turns out when you're solving problems in calculus, you heavily use quadratic functions. So that's one of the reasons. If you're not good enough in solving quadratic equations, that will take a good amount of time for you to complete some parts of the calculus. That's why it's better to be more fluent at doing calculus, like quadratic equation problems, when you start doing calculus. So there are three main ways of solving quadratic equations. So the first one is going to be factoring. So just factorize the equations and then solve it using the factors. So that's the first one. The second method is completing squares. This is another very important method. And then the last one is quadratic formula. So if the first two are not working for you, then you can do the quadratic formula, or you can just straight jump ahead to the quadratic formula. But in most cases, I don't recommend using quadratic formula because it's much easier to do the factorization or just completing squares. So let's start with factoring. So there are a lot of different ways of factoring quadratic equations. The method that I'm going to show you to factor the quadratic equations is based on Vieta's theorem. So the theorem is called, so if you remember, there was a theorem which is called Vieta's theorem. This is an Italian mathematician, and it says that the product of two roots, so the quadratic equation has two roots, and their product is this number and sum is this number. So basically what you should do is think of two numbers whose product is -80. So and then so at the same time their sum has to be 2. So in this case it's 10 and -8. If I multiply these two numbers, I get -80. 10 plus -8 is 2. So these are my numbers. And then on this side I have x squared, so you can write it as x and x. With this setup, the factorization of my quadratic equation is going to be x plus 10. So this x plus 10 multiplied by x minus 8 equals 0. So if you just open the parentheses and combine like terms, you'll get x squared plus 2x minus 80. And then at this point, you know that we can solve these two factors separately. So from here, if you set this equal to 0, the first x is going to be -10. The second x is going to be just 8, because 8 minus 8 is 0, or -10 plus 10 is 0. So when one of the parentheses is 0, so you'll be multiplying 0 by a number. So that's whenever you multiply something by a number, that becomes 0. So this one is a little bit more complicated case with parameters. So not everything is a number. We have x squared, so we are still trying to solve for x, but we have these letters a and b. So this is kind of this may look like you have like 3 letters, but it's still same idea here. Think of two numbers whose product is -4ab. So it's probably I would go with 2a and -2b, right? Because a times b, ab, 2 times 2 is 4, and one of these two numbers has to be negative, so to have this negative sign. And then the sum. So what happens if you add these two numbers? It's 2a minus 2b, right? Which is this number, just if you take out the 2. So put this x here, x here. The factorization is going to be x plus 2a and x minus 2b equals 0. Or solving the factors separately, x1 is going to be -2a, x2 is going to be just 2b. So the idea is we are treating, so unknown is still x, and we are treating a and b as some two different numbers. So what we have is two roots, negative 2a and just 2b. So this is the very primitive way of factoring quadratic equations. So this is also one thing to note here is that the leading coefficient is 1. So x squared, the coefficient in front of x squared here and here was 1. So in a more general setting, the leading coefficient may not be equal to 1. In that case, you need to do the factoring of both leading coefficient, this term, and the last free term. So think of two numbers whose product is 5. So that's, say, 5 and 1. And here, 3x, x. Again, think of two numbers whose product is 3. So I would go with 3 and 1, because 3 is a prime number. So the only possible option is 3 and 1 mostly. So 3x multiplied by x. So now here comes the very important part of this factorization when it's not a quadratic function with leading 1. So you have to multiply it like this, and when you multiply x by 5, so you get 5x, and when you multiply 3x by 1, you get just 3x, right? And this everything here total should be equal to negative 8, but in our case it's positive 8x. 5x plus 3x is 8x. So we have to change something. So you may already have noticed what to change here. So I'm going to change the sign. So I'm going to make it negative 5 and negative 1. When I multiply it like this, I will have negative 5x and negative 3x. And this whole thing together is going to be the thing in the middle of negative 8x. So that gives me 3x minus 5. So you write it in this linear order. So 3x minus 5, the first factor. The second factor is 1x. It's just x minus 1 is 0. If you solve each factor separately, you get x1 is 5 over 3 and x2 is just 1. So 2 roots. Okay, so let's go with something with parameters. So in this case, I would go with ax and just x, because a is just a number, so we don't know we don't know the factors of a. So the only factor we know is 1. So a times 1 could be a good option. And then in the middle, looking at the middle of the equation, you can see that we can see this 2 times a. So I would put 2 here, 1 here, and with negative signs probably because of this negative sign. So when you multiply it, when you cross multiply it, you will get negative 2ax and negative x. So this everything together gives me the number in between ax squared and 2, because if you take out this x, negative x and negative x, you will be left with 2a plus 1 in the parentheses. So that means the factorization of everything is going to be ax minus 1, x minus 2 equals 0, or x is 1 over a and x is equal to 2. And that's here we have one important note to make here for the first one. A is not equal to 0. If a is equal to 0, we can't divide 1 by 0. So that's something obvious to note, right? So if you put if a was 0 here, you can say this term would have been 0. This term would have been like 0, negative x plus 2. So if a was 0, so this wouldn't have been quadratic equation in the first place. So that's very simple note. That's one thing to note here in this problem. Also, there are a lot of different ways of factoring. So if you just Google and surf some books and look at different videos on YouTube, you can see that there are a lot of different ways of factoring quadratic equations. In the end, the thing that you need to know is only one way. So just master one factoring method, and you can keep using that method for all your quadratic equations. You don't need to learn several different ways of factoring one single problem. So there is no need for that. So like you'll be using this you'll be using the solving quadratic equations at most in your calculus classes. Other than that, you'd be just using calculators to solve quadratic equations. That's why there is no need to learn a bunch of different methods to factorize quadratic equations. Just learn one. For example, if your method, so like if there is a method that you know and that you can perform better than this quadratic factoring method, just stick to that method and keep factoring the quadratic equations with that method. So no need to switch to another method. So there is no method is better than the other one. So that's the idea. So the second thing, so whenever it's not possible to factorize it like this, you can use completing squares. The idea of completing squares comes from the formula of a plus b square. So recall this formula, which was like a square plus 2ab plus b square with this extra term in here. So if I subtract, so here, that's the formula for completing square usually. So if you take this b squared to the other side, or here for this one, if you take this b squared on the other side, you have x plus minus b squared, open the parentheses, so exactly this formula. So that's something you can use to complete the square. So let's see a couple examples. For example, here x squared minus, so 6 in, recall that we need 2 in the formula of square. So 6, we can rewrite 6 as 2 times 3 times x plus, if we had, like, imagine if we had this 3 square here, not just 3, and then add this 3, so we have this extra 3 squares here because of this 3, then this part would have become like x minus 3 square formula plus 3 is 9. And then if you subtract 3 from both sides, x minus 3 square is 6. So now you can take square roots. When you take the square roots, you can find x. But the catch here is you need to, so x minus 3 is going to be, since this is an equation, so the roots are going to be square root of 6 plus minus. So there are two options. And then x1 is going to be 3 plus root of 6. x2 is 3 minus root of 6. So that's the whole idea of completing squares. Let me show you another very interesting problem about completing squares. So this is not exactly quadratic equation, but it uses heavily the idea of quadratic equations. In this problem, we need to find a and b. So there is only one equation and two unknowns. But it turns out there is only one set of solutions for this problem, and that can be found using completing squares. First, let's take a look at the variables with a. Right? So here. So let's rewrite this 8 as 4 times 2. So 2 times 4, a. So that means I can add extra 4 square here. So that if I add extra 4 square, this becomes just like a plus 4 square. But this is something we don't have in the equation originally. So we have this, but let's keep that for now, plus b square minus 2 times 7, so this is here, times b, so this is going to be 14b, plus, let me write 7 square here again. That's because if I had this 7 square, this part would be b minus 7 square. So we have these two numbers, right? So, and where is this 65? So let's try to see where is this 65. This is 16 and this is 49. So 16 plus 49 is 65. So that means I already have this 65 as 16 and 49. So my equation just became like a plus 4 square plus b minus 7 square is 0. That's factorized form of my equation. So in a different way. Now if you look at these two terms of the equation, this is a square of something. This is the square of something. A square of something is always greater or equal to 0. So if it's a greater than 0, the sum is going to be greater than 0, but the equation says that it has to be equal to 0. So that's the problem. So we can't make it greater than 0, so we can make this equal to 0, and we need to make it equal to 0. So that's from where we can only have that a is -4, b is 7. If a or b are something different from -4 or 7, this square or this square is going to be greater than 0, and then on the left of equation we won't have 0. We will have something greater than 0. So that thus we can't hold this equality. So the only way to hold that equality is setting a is -4, b is 7. So that's the solution of this problem using completing squares. So the last thing, if you are completely stuck, you need to use quadratic formula, and quadratic formula is just direct formula to solve any quadratic equation, right? You just need to identify the coefficients. So in the first one, let's try to identify them. So the coefficient a is 4, coefficient b is -8, and coefficient c is 1. And for this one, this is coefficient a, so this is b and c. So whenever the number has negative sign, you take the negative sign as well. So the coefficient b is not just 8, it's something where it's -8. It takes this negative sign as well. Now the formula is the following. So instead of memorizing the whole formula, it's better to split the formula into two parts. In the first part, you need to compute something that's called discriminant of a quadratic equation. So first step is to compute the discriminant. So this is something we usually denote as a delta. It's a triangle, but it's delta, Greek delta, which is b squared minus 4ac. And then b squared here in the first problem is -8 squared minus 4 times 4, a is and c is 1. So that's 64 minus, so that's 64 minus 16, or 48. So that's our discriminant. So if this discriminant is greater than 0, so that's greater or equal to 0, it means we have some roots, real roots of quadratic equation. So we can keep solving the problem. If it's a negative number, then it doesn't have real roots. So depending on what you are solving, if you don't need complex roots, you can just stop solving the problem at this point. For example, for this one, let's try the discriminant of this one. So -2 square minus 4 times 3 times 5. So that's going to be 4 minus, so this is going to be 60. So -56. So if you keep, so since this discriminant is negative, so if you keep solving this problem, the second one, you'll get complex roots. And if you are not interested in complex roots of the equation, you can just stop it and say this equation has no roots. Since we are focusing on calculus, in calculus we don't use complex roots, so which means we just stop here. So that's our ending point. This equation has no roots because discriminant is negative. But for the first one, x x1 and x2 is going to be, now the roots are going to be negative b plus minus, so you have to do plus version and minus 1, so there are two roots. Square root of discriminant, so that's this square root is the reason why we stop here, because if you don't stop here, it's negative number, you will need to take the square root of this negative number, but in real numbers you can't take the square root of negative number, so it becomes complex number. Okay, so over 2a, so that's the roots. So negative, so we have the negative sign, and b is negative 8, so negative 8 plus minus root of 48 over 2 times 4. So in a simpler way, 8 plus minus root of 48 over 8. So maybe you can simplify this by 2 or 4 and get simpler version for this number, but this is going to be the roots of this quadratic equation using the quadratic formula. So we saw three ways of solving quadratic equation. The easiest way, so you should always go with the factoring. If it's not possible, try to do the completing squares, and the last choice is going to be to use the quadratic formula, but the quadratic formula is the most universal one, so you can use for any problem. So quadratic formula is going to solve your any problem. So but for completing square or factoring, it depends on your method and your skills, how you factor numbers or how you are able to see the squares. But for quadratic formula, it's universal.